Okay, so each value you can split. Remember, you can split at each value. So if you have 1,000 possible values, you have 1,000 possible splits. Okay, so here is a kind of an example. Suppose you have ordinal predictor. Ordinal predictor means it's categorical, but it has an order. So if you have an ordinal predictor, and if you have L possible values, L distinct values, then 2 to the power of L minus 1 is the number of ways in which you can split. So if you have an ordinal predictor and the possible values are 1, 2, 3, or 4. Okay, so maybe number of siblings, 1, 2, 3, or 4. Okay, so 1 is smaller than 2, 2 is smaller than 3, 3 is smaller than 4. In that case, there are 4 possible values. So 2 to the power of 4 minus 1, so 2 to the power of 3, 8 minus 1 equal to 7. There are 7 possible splits. Okay. Now, here are those possible splits. Okay, and here there is one more thing that I forgot to mention, that is a split can be a binary split. Binary split means what? You get a left side and a right side. That's it. There are only 2 possible branches coming out of the root node. Okay, but you don't have, that's not necessarily the case. You can have 3 splits coming, 3 branches. Sorry, not 3 branches coming out of the root. You can have 4 branches coming out of the root. You can have 5 branches coming out of the node. So here we have 4 branches coming out of the root node. So that is a split as well. So if you have, this one is the binary split, so you have only 2 branches. Now, you have 3-way split, so you have 1 branch, a 2nd branch, and a 3rd branch, right? So that would be like that. These are the possible ways in which you can have 3 branch splits. And then, of course, you have 4-way split, 4 branches. And there is only 1 way in which you can do. So these are the 7 possible ways in which you can have, you can split an ordinal variable, okay, with only 4 possible values. So 4 possible values, 7 splits. Just see that if you have 20 possible values, we end up with how many possible splits? 524,287 splits. Just that for that 1 variable with 20 possible values. Okay, just that 1 variable. So this is a problem with decision tree. So the number of splits, it just takes off after a little bit. And this is for ordinal. If you have nominal variable, okay, nominal means there is no ordering. So here ordering restricts. You cannot put 2 before, you cannot put 2 before, 3 before 2 because there is an ordering clash. But if it is a nominal variable, you can mix and match any way you want, then the number of possibilities just shoots up. Okay. So this is the formula to figure out how many. You don't have to worry about this one. You need to know how to do this. Okay, that one is easy. Okay, so if you have a nominal predictor, again, okay, so you look at the comparison between ordinal and nominal. Nominal predictor, the number of possibilities compared to ordinal predictor, number of possibilities. Even that 500,000 is just nothing when you look at the nominal predictor. So that is the problem in decision tree. The number of possible branches, okay, it just explodes. So because of this, normally speaking, we only look at binary splits. Most cases, binary split. Okay, there are some exceptions, like if you have random forest, that he talked about random forest too a little bit. Now in those cases you can have more than 2, but normally speaking, you will have only, so binary split, ordinal, these are the formulas you need to know. Okay, ordinal, if you have ordinal, there is only L minus 1. If you binary split, there are 4 possibilities, there are only 3 ways in which you can split them. If you have 10 possibilities, there are only 9 ways you can split them if it is a binary split. If you have nominal variable, then this is the number of splits that you'll end up. This is the formula that we had for all splits in ordinal. So that's the same formula here, 2 to the power of L minus 1 minus 1. And you see, these are the ordinal and nominal comparison. You see, nominal binary splits, nominal, this is the actual number of total splits, 795 billion for 20 possible values. Okay. If you do only binary, it's only 524. This is the reason why decision trees mostly use binary splits. No other splits are considered. Okay. All right. Let's stop here, and I'll see you Thursday.